Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2018 Time Zone 1 in May. So that is question number 10, something to do with topic 4, the bonding and structure. In terms of the molecular geometry deduction, let's see. They're asking, what is the molecular geometry and the bond angle? Asking two things. The first thing, the real shape. As mentioned before, molecular geometry is something that different from the what we call electron domain geometry. Hopefully students get to know what the difference are. Secondly, they're asking for the bond angle. So that is something within the bonding elements that creates an angle. In the molecular ion, the importance of this question is going to be whether student can recognize what we call the Lewis structure of this special polyatomic ion. Nitrate NO3-, right? Because remember, the skills, or you can say the steps, in terms of deducing bond angle or molecular geometry is that the first step that we must do is we need to recall the Lewis structure. Lewis structure, simply known as the dot and cross diagram, that represent all the electron pairs, no matter lone pair, bond pairs, within these kind of ions, right? And then what we do is to try to look at the central atom's total electron domain number and try to see the combinations of the bonding domain and then finally lone pair and see the combination and finally deduce the case with the total electron domain and how many possible combinations are there, and so we deduce the real shape. So let's see. In this case, first of all, Lewis structure. Not so difficult is that students should have realized that nitrate is a special case in our topic 4 in terms of the situation of delocalization, because the N is now bearing a positive charge normally and then having a simple double bond with the oxygen. So that's why this oxygen is really satisfied, while having negative charge on each of the two other oxygens, having an extra electrons, right? So this is the Lewis structure, right? So the whole thing will be one negative charge, one of the really classical presentation of nitrate. The delocalization exists within this what we call the pi bond. This pi bond will be a little bit naughty in a way that it will jumping across the three domains of the NO pattern. So what we call the pi delocalization. But this is not the important thing in this question. The most important thing is we need to carefully look at, so this is the first step. Second step, look at the central atom of this compound. So the central atom will be nitrogen, right? And then we count the number of electron domain. As mentioned before, electron domain regardless of whether this is going to be a single, double, or triple bond, all bonding count as one domain. So here comes one domain, two domains, and three domains, right? And finally count the lone pair. So in this case, surrounding the central element, there's no lone pair electrons, right? Because nitrogen, if it is going to be +1 charge, it will be having only 4 electrons. 4 outermost shell electrons already totally used in forming all the covalent bonds, right? So that's why here no lone pairs. So that's why the combination of all the electron domain will be with a free situation, 1, 2, 3, with all bonding domain plus 0 of the lone pair. So this is the spell that we will have every time. The outcome, after having Lewis structure, deduce from the central atom, the total electron domain equals to the total number of bonds plus the total number of lone pair electrons, right? LP electrons, right? I simply say, so lone pair electrons, right? So in this case, no lone pair, so all the electron domain goes to the bonding domain. And then finally, refer to something that students should have memorized, that with the different total number of electron domain, 3 based on 3 plus 0 will be a trigonal planar, and this trigonal planar will have all the angles equivalent to 120. Easy, because the full planar structure having 360 evenly divided by 3 times, so each of them shares 120. So and eventually the answer going to be B.